The moon, our little buddy in this trip through the cosmos. Sometimes it's there, sometimes it's not. I mean, have you ever looked up in the sky and seen the moon look like this? Or this? How about this? Have you ever wondered why sometimes the moon is nowhere to be seen, yet sometimes it's fully illuminated high up in the night sky? Well, in today's video, I'm going to go over the phases of the moon, how its position in its orbit around Earth has a direct effect on what we see, why we only see one side of the moon, and much more. But before we start, make sure to subscribe for new astronomy and astrophysics videos coming soon. Now, as always, any information I found for this video will appear as a number like this on the screen, which will correspond with the number in the description down below. They'll have a citation and link for where the information was found. So, to first understand why the moon goes through phases here on Earth, we have to understand that the moon orbits the Earth. This diagram from NASA and JPL Caltech allows us to easily visualize the moon's orbit around Earth and to understand how it corresponds with the phases we see. The moon takes a little over 27 days to complete one orbit around the Earth. However, although it takes the moon 27 days to complete an orbit around Earth, it takes the moon 29.5 days to go through all its lunar phases. The reason why is that as the moon orbits the Earth is also orbiting the sun. The moon has to travel a little bit further to make up for the distance that the Earth has traveled in order to complete the lunar phases cycle. So, we understand that the moon orbits the Earth, and it takes the moon 29.5 days to complete the lunar phases cycle. So what does that have to do with what phase we see from here on Earth? Well, as we will see, the position of the moon in its orbit around Earth will have a direct effect on what phase of the moon we see here from Earth. As I go through the phases of the moon, I'm going to set up a do-it-yourself model that you can do and follow along with at home. All you need is a light source, such as a lamp or flashlight, and a spherical object. This can be something like a tennis ball, an orange, anything that resembles a rough sphere, and it doesn't have to be too big. In my case, I'll be using putty that I've rolled into a rough spherical ball attached to the end of a pencil, and I'll be using a lamp as my light source. The new moon. The lunar phases cycle starts with the new moon. It can be thought of as the start of day 1 of the 29.5 day cycle. A new moon occurs when the moon is positioned between the Earth and the sun. From Earth, the new moon will rise and set with the sun in the sky. When we have a new moon, the moon is invisible from Earth. The reason why is that there is no illuminated surface of the moon that can be seen from Earth's perspective. You can see this yourself with your at-home model. Take your spherical object at arm's length away and put it between you and your source of light. Notice how there's no part of your sphere that appears illuminated from your perspective? That's because the part that is illuminated is on the other side of your moon. In some cases, the moon may pass in front of the sun, causing a solar eclipse, but we will get to that later. Waxing crescent moon. The waxing crescent moon occurs when the moon is starting to move away from the sun in its orbit around Earth. A waxing crescent moon is the name given to the moon that is past new but is before first quarter. A waxing crescent moon will rise mid-morning and set in the evening. You've probably seen waxing crescent moons before, just after sunset, not too high off the horizon. Going back to our at-home model, take your sphere at arm's length away and begin to turn counterclockwise from your light source. You will notice that the spherical object you're holding will start to have an illuminated surface from your perspective, going from no surface at your new moon into a crescent fingernail-like appearance. When talking about the moon, the term waxing means growing. So in our case, waxing crescent simply means growing crescent moon. First quarter moon. The first quarter moon occurs when the moon has completed a quarter of its lunar phases cycle, leading to half of the moon's surface to appear illuminated from Earth. From the northern hemisphere, the right half of the moon will be illuminated by the sun, while the left half will not be. If you live in the southern hemisphere, this will appear the other way around. I'll go a little more in detail about how your latitude on Earth affects how you see the phases of the moon after we've gone through all the phases. In our model, continue turning counterclockwise so that way your outstretched arm holding your makeshift moon makes a 90-degree angle with your light source. You will notice half of your moon will be illuminated. A first quarter moon rises at noon and sets at midnight. Waxing gibbous moon. A waxing gibbous moon occurs when the moon is between the first quarter and full moon. From the quarter moon, the illuminated face on the moon will continue to grow across the surface. Waxing gibbous moons rise in the mid-afternoon and set just before dawn. In our model, continue your counterclockwise turn from your first quarter position and take notice of how the light-lit portion continues to grow on the surface of your makeshift moon. Full moon. A full moon occurs when the Earth is between the sun and moon. It can also be thought of as when the moon is at its furthest point away from the sun in its orbit around Earth, or when the moon has completed half of its lunar phases cycle. During a full moon, the surface of the moon will appear fully illuminated from Earth. A full moon rises at sunset and sets at sunrise. In our model, turn your back to your light source and hold your makeshift moon up so that way the surface of it is fully lit. This resembles a full moon. Now, if you held your makeshift moon in a position that your head blocked any light from hitting it, this would be a good representation of a lunar eclipse, which we will get to later. Waning gibbous moon. After the moon has reached full, the area of illuminated surface will begin to shrink as the moon goes through its orbit. We can see this with our at-home model. With your back to your light source and makeshift moon held out, continuing your counterclockwise turn from full moon position. You will notice that a portion of your makeshift moon will begin to become dark again. Waxing gibbous moons rise in the late evening and set just after sunrise. The word waning means to get smaller or to shrink when speaking about the moon. Third quarter moon. The third quarter moon occurs when the moon has completed 3/4 of its lunar phases cycle. From Earth, the surface will appear half lit just like in our first quarter moon. However, unlike our first quarter moon from the northern hemisphere, where the right half of the moon was lit and the left half was dark, this time it's the other way around. In our model, continue your counterclockwise turn from waning gibbous until only the left half of your moon is lit. You should once again be making a 90-degree angle with your light source. The third quarter moon rises at midnight and sets at noon. Waning crescent. The waning crescent moon is our final moon phase before the moon completes its orbit around Earth and becomes new moon again. A waning crescent moon rises just before dawn and sets in the mid-afternoon. If you've ever seen a crescent moon just above the horizon before sunrise, you've seen a waning crescent moon. Going back to our model, continue your turn from third quarter moon and notice how once again the moon becomes a crescent until it has finally reached new moon once again. Now, depending on your latitude, the moon will appear to go through the phases in a slightly different way. This might sound a little confusing, so to better visualize this, here's the moon going through all its phases from the northern hemisphere. And this is the moon going through all its phases from the southern hemisphere. So, I mentioned earlier that sometimes in the moon's orbit around Earth, it may cause solar or lunar eclipses. Well, what are these? Solar eclipses. Solar eclipses can only occur during a new moon. Solar eclipses occur when the moon passes in front of the sun in the sky. The moon's shadow lands on the Earth, and if you're lucky enough to be in the path of totality, you will witness the moon completely block out the sun in the sky, creating one of the most beautiful events that nature has to offer. Lunar eclipses. Lunar eclipses can only occur during full moons. Lunar eclipses occur when the moon passes into the Earth's shadow. Sunlight refracts in Earth's atmosphere, which then lands on the moon's surface, giving it a deep red color. So, you might now be thinking, why don't solar and lunar eclipses occur every month? Well, the reason why is that the moon's orbit around Earth isn't flat. The moon's orbit around Earth is actually tilted at about a 5-degree angle. This means that sometimes during new moons, the moon's shadow is casted either above or below the Earth, and during full moons, the moon is either above or below the Earth's shadow. This causes what we call eclipse seasons. This diagram allows us to more easily visualize this concept. If you want to know more about solar and lunar eclipses, the different types of eclipses that happen, and a more in-depth explanation about the science behind them, don't worry, I'll be releasing a video soon going more into detail about solar and lunar eclipses. Now, you might have another question as well. Why do we only see one side of the moon? If the moon orbits the Earth, shouldn't we see it rotate and see different parts and sides of the moon other than just one? Well, the reason we only see one side of the moon is due to tidal locking. Without going into the physics behind it, what this simply means is that the moon makes one full rotation on its axis every 27 days. The amount of time it takes to complete one orbit. What this means is that as the moon orbits Earth, it's also rotating at a rate that we only see one side. This diagram here allows us to visualize this concept of tidal locking. Notice how in a tidally locked system, the face of the moon stays pointed at Earth because it's rotating at a rate that allows us to see the same face. While in a non-tidally locked system, different parts of the moon can be seen from Earth depending on where it is in its orbit. Now, if you were to observe the moon every night through the course of a lunar cycle, you might notice something a little odd. It will seem like the moon is wobbling over the course of the month, with some features near the edge of the moon coming in and out of view from your perspective on Earth. This could be more easily seen by speeding up the lunar phase's cycle. This wobble is called libration. Libration occurs because of three distinct factors. First, the moon's orbit around the Earth is not a perfect circle. It's a bit elliptical, meaning at one point in its orbit, the moon is around 356,000 kilometers from Earth, and at another point in its orbit, the moon is around 407,000 kilometers from Earth. This means that the moon speeds up a little bit in its orbit near its closest approach, 356,000 kilometers, and slows down a bit at its farthest approach of 407,000 kilometers. This change in speed allows us to see a little extra portion of the western and eastern edges of the moon. This is called libration in longitude. The next factor goes back to the moon's 5-degree tilt of its orbit. This causes the moon to tilt up and down a little bit and allows us to see a little bit more of the northern and southern edges of the moon. We call this libration in latitude. Finally, the moon over the course of a lunar cycle will appear to tilt back and forth, and this is caused by the Earth's axis being tilted by 23.5 degrees. So, after all this, you might still have one question remaining which I want to touch on. Why can you sometimes see a dim outline of the dark surface of the crescent moon even though the sun isn't shining on it, like seen here in this photo? The reason is due to something called Earthshine. Earthshine occurs when sunlight bounces off the Earth and is reflected back into space. Some of that light that is reflected by the Earth lands on the moon, allowing the unlit portion of the moon to be dimly seen. So, there you go. The phases of the moon, eclipses, tidal locking, libration, and Earthshine. If you want to know what phase of the moon is currently visible, NASA has a nice and handy moon phase calendar, which I'll drop in the description down below. So next time you are with your friends or family and you see the moon up in the sky, don't be afraid to flex some of your knowledge on them. Well, that's it for me. If you want to see new astronomy and astrophysics videos, make sure to subscribe for new videos coming soon. Until then, I'll see you in the next video and take care.